Okay, in this video we are going to look at starting off with higher degree polynomials and kind of what those look like, as well as the different parts of a polynomial and how to identify the pieces. So first of all, this is what a generic polynomial looks like, where you have an unknown degree level, hence x to the n. The little numbers up here are what tells you your degree. Well, in a polynomial, we go from what's called leading term all the way down to what's considered your constant term. When we talk about a leading term, we are talking specifically about this first term. We call this your leading term. With that leading term, the other thing that we also get from it is we get the degree of the polynomial. Now, with that being said, we also have what's called your constant. So your constant is always going to be your last term here. So this is your constant. And what's important about your constant is, remember, constants mean no variable. Constants are just your numbers. Okay. Now with that, we can determine what different types of equations are in terms of their labels. For example, linear, quadratic, cubic, etc. So here I have this table, and in this table we have what's called your polynomial function. That's the name. Okay, so when we're talking about your polynomial function here, we are talking about the actual name of your polynomial. This next column are different examples. So in other words, when we're talking about our constants, we could have it look in two different ways. First, we could just say that my function equals 7. Notice there's no variables off to the side, it's just a straight number. The other way you could see this would be 7x to the 0. Now the reason why we know that is because you need to remember the rule, which says that anything raised to the 0 power equals 1. Therefore, this would be the same as saying x times 1, or 7 times 1, which is just 7. Now with that, your degree is going to come purely from your highest x power term. So when we're looking at a constant, we don't have it, therefore your degree has to be a 0. Now your leading term is going to be the term that comes first in your problem. So here, the only thing we have is a 7. So my leading term here is a 7. The leading coefficient is essentially the same thing as thinking about your lead number. So remember, coefficients are the numbers attached to your variables. So in this constant case, again, the only thing I have is a 7. Even if we look at the second thing, 7x to the 0 power, my leading coefficient is still going to be your 7. Now linear is the next one down, because linear essentially means power of 1. And so if we look, an example here might be 3/4 x plus 10. So here, if you're looking at your x term, notice that it doesn't have anything listed up here as its power, which means we can assume that this is the power of 1. Therefore, again, when we're talking about degree, we are talking about your first degree. Now again, your leading term is the entire term. So term means numbers and variables. So my leading term here would be 3/4 x, which means my leading coefficient is going to be the 3/4. So notice the variable drops out, but the variable is included under your term. Quadratic, of course, is power of 2. So here again is an example. So when we talk about degree, quadratics have a degree of 2. In this example here, my leading term would be 10x squared with a leading coefficient of 10. Okay, hopefully you can start to kind of see the pattern. Cubic is going to be power of 3. So in this example, my degree here is going to be 3. My leading term is negative x cubed, which makes my leading coefficient a negative 1. And last I have what's called a quartic. Quartic is going to be power of 4, so the degree is 4. And in this example here, that leading term would be negative 1/4 x to the 4th, making that leading coefficient negative 1/4. And of course, and so on and so forth. So you could go much higher. When we're talking about higher degree polynomials, we are usually talking about cubic and higher. And that's because in most algebra classes we stop at the quadratic. So cubic and higher is usually going to be our higher degree polynomials, and that's where we focus here in pre-cal. Now there's some characteristics that we have to pay attention to when talking about polynomials. So the first thing again is that we have that leading coefficient being the number in front of your highest degree term. Okay? So here we're talking about the number in front of the highest degree term. Now the leading term is going to be that entire term. So in this case we're going to include the variables. So here we are going to include your highest degree variable. The degree is this little n value. So notice when we're talking about this leading term, the n is your power. So when we're talking about your degree, we are talking about your highest power. Now, continuous means the way the graph looks. So when we're talking about a continuous graph, what that means is that there are no breaks or gaps. In other words, when you put your pencil down in one part of the graph, you can draw that pencil straight through without having to lift it. Okay, this also means that we are talking about smooth curves. Now, last but not least, our domains. For most of our higher level polynomials, your domain is always going to be all real numbers, because with most of these, we are not going to come across an x value where we have an issue. Okay? Now, we have a couple concepts and ideas that we use to kind of analyze some of these higher level polynomials, and the first is called a leading term test. Your leading term test is going to help you determine what's called the end behavior. So the end behavior of your polynomial. In other words, what is happening when we are thinking about the infinite spectrum. Okay? Now, your behavior is determined by the sign. Okay, so one thing that we call your end behavior is we call it the tails. So it is the tails of the graph. Now, when we're talking about, again, your leading term, you need to remember that you are going to use only the term with the highest degree. Okay, the rest of it does not matter. We're just simply using that highest degree. So we've got a couple cases here. First, we have what's called even degree. So even degree has two possibilities. Either both of your tails are pointing up or both of your tails are pointing down. So to have both tails pointing up, this means that we have a positive leading term. And so when we label it, it's called positive, and we label it by saying that the tails are going to point up. That means if we look at this blue case here, my tails are pointing down. So this would be your negative case. which again means that your tails are going to point down. Now, odd degrees also have two possibilities. With odd degrees, your tails are always going to go in the opposite directions, and so what those directions are doing is what matters. If you start on the leftmost side, okay, so when you read your graph, you are always going to read from the left side through to the right. Okay, so if you start at the left and you draw your pencil and you notice that your pencil starts by going in an upward direction and finishes by going in an upward direction. What this means is that you have a positive. And in this case, we would label it by saying that the tail points up on the positive x and points down on the negative x. Okay? But this is called a positive. That means the opposite is true. Again, if you read from left to right, and you start and you notice that your pencil is going to draw in the downward direction to start, and you are going to finish in the downward direction at the end. So notice the stuff that happens in the middle doesn't matter. Well, then we would call this a negative. And in that, you would have that your tail points up on the negative x and that it points down on the positive x. So when you're classifying, you have to first be able to identify, are you even or are you odd? And then what is that leading term doing? Is that leading term positive or negative? And therefore, what should that graph look like? Okay. So here let's look at a couple examples just so you could see how this would work. So here in this problem, you need to determine the leading term, the leading coefficient, the degree, the end behaviors, and then classify it as constant, linear, quadratic, cubic, or quartic. So in this first one, what you always need to check is you always need to check that the equation is ordered from greatest to least. In other words, it should be in descending order, which is the standard way that equations should be written. So if we look at this one, notice I have a power of 4, then a power of 3, power of 2, power of 1, and then nothing. So this one is written in order the way it should be. So the first thing we need to identify is we need to identify your leading term. So remember that is the first term. So here the very first term of your equation is what we're looking at. So my leading term would be the 1/4 x to the 4th. We also need to identify your leading coefficient. Remember, the leading coefficient is the number, so this would just simply be 1/4. So it's the number attached with that term minus the variable. Now, when we're talking about that degree, again, we are talking about the highest degree level, so here it would be 4. Last but not least, we need to look at your end behavior. So the first thing that I would do is I would take a couple of notes. So here, my degree is power of 4, so that means that this is going to be an even. And even means that your tails point in the same direction. So what exactly is the end behavior? Well, not only is it even, but if you notice, it's also positive. Therefore, my end behavior is going to be that my tails are going to point up. Okay, that's the end behavior. And then last but not least, we have to classify. Well, if you remember from the chart on the previous page, a power of 4 is classified as a quartic. Okay, so notice we're not graphing, we're not solving, we're not doing anything else except for identifying and analyzing the proper terms out of your equation. Alright, let's look at one more here. So notice here I have power of 1, power of 4, power of 5, power of 3, and power of nothing. So the first thing I have to do is I need to rewrite it. So this should really be f of x. And then you need to start with your largest degree. So this is going to be 2/5 x to the 5th minus 2x to the 4th plus x cubed. I don't have any x squareds, so minus the 1/2 x and plus 3. Now that it's ordered properly, I can identify the first term that I am working with. And now I can identify my pieces. So first I have my leading term. So my leading term is going to be the 2/5 x to the 5th. This makes my leading coefficient that 2/5. My degree is a degree of 5. My end behavior first is positive, second is odd. So when we have positive and odd, what we have to remember here is that your tails are opposite. So with that in mind, because I have positive odd, what that means is that my tails are going to point up on the positive x and down on the negative x. And then last but not least, we have to classify. So this one, because we're now starting to get into bigger numbers, so greater than 4 or even at 4, we would classify this as called a 5th power. It also has a term, you could call it a quintic, but most are perfectly fine when classifying it as a 5th power. Okay? So same here with your 4th power, you could call it a quartic, or you could simply have listed it as 4th power. Now this does not hold true with cubic and quadratic. We don't label those as 2nd power, 3rd power. We actually labeled them as quadratic and cubic. But the higher you go, the more simple it becomes in that the degree is part of its classification. So that's everything that you would need to know to get started with being able to identify and classify higher degree polynomials. So if you have any questions, please let me know. Otherwise, enjoy, and I will see you next time.